So lesson 2.5, creating and solving compound inequalities. Your essential question is, how can you solve a compound inequality and graph the solution set? So when you combine two or more simple inequalities, that forms a compound inequality. Our last 7 notes we were talking about inequalities, and here we're going to look at some compound inequalities. All right, so compound inequalities, and so you might have something that says all real numbers greater than 2 and less than 6. So the algebra for that would be you could write it separately. X is greater than 2 and X is less than 6. But since we're writing two inequalities that are both using X, you can rewrite it into one compound inequality. 2 is less than X is less than 6. And then the way you would graph this example is on a number line, you would have an open circle at 2 and an open circle at 6. Okay, these are the less than symbols. They are not less than or equal to. Less than or equal to would be a filled in bubble, but these bubbles are not filled in. They're circles and they're open. They're open circles. Okay, because they're not including that number. And then you would shade the line in between. The next one here, all real numbers greater than or equal to 2 and less than or equal to 6. So separately, I would have X is greater than or equal to 2 and X is less than or equal to 6, but I can combine them into a compound inequality where X is in the middle, and I could read this as 2 is less than or equal to X is less than or equal to 6. This is graphable by putting a closed circle at 2 and 6 on my number line and then shading the values of X that make it true, which are all in between. So the difference between these two and ones are the open circle or the closed circle, depending on which inequality you have. So those are for and. For compound inequalities with or, a phrase might be all real numbers less than 2 or greater than 6. And so what that would look like is X is less than 2. The word or, X is greater than 6. This is not a compound inequality in the sense that it's written in one combined sense, but it is a compound inequality because it includes the word or. You would have to write this whole statement to represent it. So with the and ones, you have an option of how you write them. You can use the word and or you can write it where it's kind of condensed and shorter. But with the or ones, you have to write it out with the word or. So the way this is graphed is there's a graph where X is less than 2, and there's a graph where X is greater than 6. So the or is what we're showing here. X is less than 2, open circle, shading less than 2, numbers that are less than 2. X is greater than 6, open circle, all numbers that are greater than 6, it's shading with arrows pointing in those directions. That's important too. There's no arrows on these and graphs, but there are arrows on the or graphs. All real numbers less than or equal to 2 or greater than or equal to 6. So the way we would write that out with symbols in algebra is X is less than or equal to 2 or X is greater than or equal to 6. It's important that you include the word or. And then if we graph it, we're going to have first this graph, X is less than or equal to 2. So at 2, because it's the less than or equal to sign, it is bubbled in. It's a closed circle, and there's an arrow pointing to the left where all values are, in fact, true. They are less than or equal to 2. And then for X is greater than or equal to 6, we have a closed circle at 6, and then it's shading in the direction with an arrow all values that are greater than or equal to 6. So we have compound inequalities with and compound inequalities with or. When they're with and, you can actually simplify them into a shorter way of writing it. It's not necessary, but you should recognize it. And then the graph looks like a segment like this. Okay, it's the intersection. And then or, we would write out both of them, include the word or, and you have two basically rays graphed on a number line. And just be careful about your circles, if they're open or closed. So if they're open, that means you're not including that number. If they're closed, it means you are including that number. Okay, so this is a Pear Deck interactive slide for you. And explain why 2 is less than or equal to X is less than or equal to 6. can be considered the short method for writing the and compound inequality of x is greater than 2 and x is less than or equal to 6. The two simple inequalities can be connected at x to form one compound inequality. Okay, so we were just looking at that on the last slide for the and compound inequalities. That's something you can do. So what I would like you to do is show me how can I take what's in the green box. What is the short method to write that compound inequality? So your compound inequality is x is greater than or equal to 0 and x is less than 6. What would that look like? And you can use the text typing tool or you can draw, but you are going to give me an example of that. So you're back on your Pear Deck slide right now. So everyone should be on the Pear Deck tab, and you're using the drawing tools or the text tools to write an inequality. There's an example done for you above. So the example of x is greater than or equal to 2 and x is less than or equal to 6, you put the x in the middle, and then you include the symbols that are given in the order that makes sense with the two numbers that are given. So you're going to do the same thing with what's in the green box. So I'm trying a new feature of Google Meet, which is sharing a Jamboard with you guys. So I believe you can open up and see what I'm writing on here. It's a link that showed up in your Google Meet chat. So basically, we have let's see, if you use that link, see it's in your Google Meet chat. Try it and see if it'll open up the Jamboard. I don't know how that works exactly. Okay, so Gia was able to do it. So yeah, it's in the Google Meet. I'll share it in a second because I do want to share the answer with you guys after you try this. Or if you just want to see the answer sooner. Oh, I see what I could do to do that. Okay, that's good. Let me share with you what you guys are writing. So if I show your responses, we're kind of lost. Okay, so right here, x is less than 6, yes. X is greater than 1, so x is greater than or equal to 0. You want to include that x could be any number greater than or equal to 0. You're close, Kobe. Yes, so we circled what we're trying to use here. So I see we need a little more guidance with this. So what I'm sharing with you right now, from that problem, we're comparing x in two things. So x is in the middle. We know it's less than 6. We also know that 0 is less than or equal to x. And notice that when I had to include the 0 and the x here, I included this symbol. Because if we think about like an alligator mouth, in the original problem, it's trying to eat the x. Okay, and so same thing when I do the compound inequality, it's still trying to eat the x. And then I want to include the or equal to part of that symbol. Okay. So we're going to write a compound inequality to represent the indicated quality control level and graph the solutions. The recommended pH level for swimming pool water is between 7.2 and 7.6, or 7 2/10 and 7 6/10 inclusive, right? Inclusive means that those numbers also count towards our solution. So 7 2/10 is less than or equal to whatever the pH level is less than or equal to inclusive of 7 6/10. So we take this information out of the statement, and this is what the compound inequality would look like. 7 2/10 is less than or equal to P, which is less than or equal to 7 6/10. So it includes all values inclusive of the two n values and everything in between. And if we graph the solution, because these are the less than or equal to symbols, these are closed circles. You have one at 7 2/10, you have one at 7 6/10, and then it's shaded everywhere in between. Okay, so I'm going to have you guys write a compound inequality to represent the indicated quality control level and graph the solution. So here's a different problem. The recommended alkalinity level for swimming pool water is between 80 and 120 parts per million. So that's also inclusive, like we just had on the last problem, which means we're going to use those same symbols that we had on the last problem. So what is this going to look like? So I have 4 of 25 responses. So you do want to put something on that number line to represent the situation. So this is great right here. This first example that I'm bringing up and sharing with you guys. We have closed circles, one at 80, one at 120, and then it's shaded in between. That's exactly what you want to do. Okay, and they wrote it here, 80 is less than or equal to they said pool water is for their variable, and then is less than or equal to, you know, they might still be working, so or equal to 120. So Larry and Kobe are arguing over basketball. Looks like some of you are using the circle tool. Okay, this is good. You definitely want this. You want a closed circle at 80 and a closed circle at 120. And then you're going to shade in between. Like a combination of this and that is exactly what you want. You guys are probably still working on it. Okay. There we go. They have that and that. So I'm guessing this is Kobe. You need to put the line right here underneath your less than symbol. I'll leave it right here. This one's great. All right. We're going to move forward. Okay. So we're going to talk about absolute value. And you have learned about absolute value before, but just to remind you, the absolute value of x is denoted with 2 vertical lines and then x in the middle. We'd read that as the absolute value of x is the distance of x from 0. When you find absolute value, you can think of it as finding distance from 0. This is why absolute value is never negative. Absolute value only asks how far, not in which direction. It's never negative. This means not only that the absolute value of 3 equals 3, because 3 is 3 units to the right of 0, but also that the absolute value of negative 3 also equals 3, because negative 3 is 3 units to the left of 0. So given an inequality in the form, the absolute value of x is less than a. This is a situation that gives us a solution of the form negative a is less than x is less than a. So it's a compound inequality. So we're going to look at an example here. In absolute value, I have the absolute value of 2x plus 3, that's less than 6. So I can rewrite this using this rule where the thing that we're taking the absolute value of goes right in the middle. And then what we're comparing it to is less than 6. Well, negative 6 is less than that, and that's less than 6. I'm just using the rule right above. And then when you solve an inequality like this, it's like solving an equation, but instead of doing the same thing to both sides of the equation, you're solving a compound inequality. So you do the same thing to all 3 parts of the inequality. It's like solving an inequality where you do the same thing to both sides, but here we're going to do the same thing to all 3 parts. So when solving an inequality or an equation, you're always trying to isolate your variable. And the variable in this case is x, 2 times x plus 3. First, I need to deal with the plus 3. So I do the inverse operation. I subtract 3. And notice that I'm subtracting 3 from all 3 sections of this compound inequality, which then simplifies. Negative 6 minus 3 is negative 9. Positive 3 minus 3 is 0, so I'm just left with the 2x term. 6 minus 3 is 3. I'm almost done. I need to isolate x. X is being multiplied by 2, so the inverse operation of multiplication is division. We're going to divide all parts by 2, which then gives me the solution. If I'm asked to solve an inequality that includes absolute value where we have less than. This is what happens. This is the rule. This is an example. Okay. Let's see how good you guys are at graphing fractions. Fractions always scare everyone. All right, so you're going to graph this solution. You're going to graph this compound inequality. So x is all values that are greater than -9/2 and all values that are less than 3/2. You first need to figure out where is -9/2 on that number line. And because it's a less than symbol, you're going to put an open circle. I'm not exactly sure if Pear Deck gives you an open circle tool, but that does give you the drawing tool, so you can draw an open circle. And then you're going to find out where 3/2 is. What is that equivalent to? And again, because it's less than, you're going to put an open circle. Okay, so let me, oh wait, not yet. -9/2, -9/2. If you change that fraction into a decimal, it is a decimal. It's -4 5/10. So you should have an open circle at -4 5/10. Okay, so let me show you so far code. Oh, wait, that's pretty close. I think it's just the way the tools are. So this is great. This is Kobe. Okay, -9/2 is -4 5/10. That's in between -5 and -4. This is an open circle, and it's the best, I'm sure, that we can do with the tools that were provided. It's representing an open circle. And then 3/2 is the same as 1.5, which is here, and there's another open circle, and everything is shaded in between. This is exactly what you want to do. Open circles are not something that's easily drawn in Pear Deck. Okay, so that's why they look like squares, and that's fine for what we're trying to do. Okay. The other thing I want to cover with you is absolute value of an inequality. Now, instead of less than, we're looking at greater than. Given an inequality, the absolute value of x is greater than a. The solution always starts by splitting the inequality into two pieces. So we have a compound OR inequality. X is less than -a, or x is greater than a. For example, the absolute value of 2x minus 3 is greater than 5. We're going to use this rule right above here to come up with the two inequalities of 2x minus 3 is less than -5, because the a, looking at less than -a, or 2x minus 3 is greater than +a. We're going to solve these two inequalities by just solving them at the same time. We're solving two problems at the same time. So 2x minus 3 is less than -5. You add +3 to both sides, so 2x is less than -2. For 2x minus 3 is greater than 5, we're going to add +3 to both sides here as well. 5 plus 3 is 8, so 2x is greater than 8. And now we're going to solve these two inequalities. Isolating the x on both of these problems, we need to divide both sides by 2. So 2 divided by 2 is 1. Negative 2 divided by 2 is negative 1. 2 divided by 2 is 1. 8 divided by 2 is 4. So this is the solution to this inequality with absolute value when it's greater than. You get to graph again. This is your last part of the pear deck presentation. You're going to graph x is less than negative 1 or x is greater than 4. This one should be easier. You don't have to graph fractions. Less than, greater than, these are open circles. I did not anticipate it'd be so difficult to draw an open circle in pear deck, but now I know. So if you're doing open squares, because that's what it's letting you do, I get it. Oh, you know what you probably could do? You probably could do like a circle drawing tool of like a big circle and then do like a smaller one in white, and then that would make it look like an open circle, like a layered effect. I don't know if that would actually work, but it might. So don't use closed circles. Try to create something that looks like an open circle. The only time you use closed circles is when you have the half of an equal sign underneath your symbol. This at -1, this does look like an open circle. It was for a second, but it goes further than 0. It goes all the way up to 4. Oh, this is great. Look at this. These are circles. You did it. Let me see who did that. You're able to do it. Viviana was able to do open circles. Nice job. Okay, and this is exactly what you want. You have an open circle at -1, and it's filled in. Wait. This is almost correct. X is less than -1. So I'm not shading this way. This is the one where we shade going outwards with arrows. If this was an and statement, that's when it's one solid piece, but it's going in the opposite directions. But we have the circles where they need to be. We just need to be shading in the opposite way. Let me see if I can screenshot this and show you. Okay, I'm going to turn off my camera for 1 second, and I'm going to present to you instead my entire screen. Okay, so we can see this one that we're trying to do. Okay. This is a lesson symbol. That means we have a open circle at -1. X is less than -1. So we got a shade. This way. These are where all the numbers that are less than -1. And then for x is greater than 4, well, I'm not going to include 4, but I have an open circle, but greater than, I got to go this way. So I'm sorry my number line isn't large enough, but you can still do this. Okay, so this is what you want. And just because it's that or statement, you have the two pieces graphed. When it's an and statement, you have the single segment Okay.